The first question says, a cannonball is launched from the top of a cliff at 11.5 meters per second and lands 38.2 meters away from the base of the cliff. How tall is the cliff? So the first thing to remember is that you have this automatic built-in given in every single question, and that is acceleration is equal to 10 meters per second squared every single time. Write that down before you do anything else. Then we're looking at our givens. We've got 11.5 meters per second. And you need to know if this is the horizontal or the vertical velocity. The meters per second tells you it's a velocity. You have to figure out if it's talking about the x or the y direction. Now your key word here is it's launched from the top of a cliff. If you think about launching something off of a cliff and then it's going to fall down, you're launching it horizontally. So we can say that our Vx, or velocity in the horizontal direction, the x direction, is 11.5 meters per second. We know that it lands 38.2 meters away from the base. So meters is your clue that we're dealing with a displacement. And again, you have to figure out, is this talking about in the x direction, horizontally, or the y direction, vertically? And again, here's our key words. It lands that far away from the base. So we know that this is our dx, our horizontal displacement. And we're looking for how tall is the cliff. Keyword is tall. Remember, if you measure how tall something is, you're going to measure it vertically. So this is our vertical displacement, dy, is what we're looking for. We have our equation for dy. dy is equal to 1/2 times a times t squared. But notice that we're missing our t, our time. So we have to go back and find time as well. When you look at your equations to solve for time, you'll notice you have two choices. One that uses dy in the equation, and one that uses vx and dx in the equation. Since you're looking for dy, you can't use it in an equation to solve for something else. So you have to use the other equation. In this case, we'll say t is equal to dx divided by vx. Plug in the values that you know, 38.2 meters divided by 11.5 meters per second, and you get a time of 3.322 seconds. Now we can take that time value and plug it into our original equation up here to solve for dy. And we get 1/2 times 10 meters per second squared times 3.322 seconds, squaring that value. If you plug all of that into your calculator, you get a height for the cliff, how tall is the cliff, of 55.2 meters. Number 2 says, a hunter aims at a target on the same level as his rifle. If the bullet leaves the rifle at a velocity of 142.9 meters per second and hits 0.39 meters below the target, how far away is the target from the hunter? Again, we have our built-in given, acceleration is equal to 10 meters per second squared. We know we have a velocity of 142.9 meters per second. We know that that's a Vx because if you imagine someone aiming a rifle, they're not aiming it vertically straight up into the air. They're aiming it horizontally at a target that's in front of them. So our Vx is equal to 142.9 meters per second. Our bullet hits 0.39 meters below the target. When we talk about something being above and below, we're thinking in the vertical direction, up and down. So we know that this is our dy, our vertical displacement, 0.39 meters. We're looking for how far away is the target. We know that how far is looking for displacement. We already have the vertical displacement, so we must be looking for the horizontal displacement, or our dx. We look at the equation for dx, and it's equal to vx times t. Again, we're missing a piece. We don't have our time. So you go back to your equations, and you see that you've only got one that uses the variables you have available to you, and that is t is equal to the square root of 2 times dy divided by a. When you plug in your values, 2 times 0.39 meters divided by 10 meters per second squared, you get 0.2793 seconds. Now we can go back to our original equation, plug in the values that we know again, and we get a horizontal displacement of dx of 39.3 meters. Question number 3 says a ball is kicked off a building 10.1 meters tall and lands 27.7 meters away from the base of the building. What is the ball's horizontal velocity? Our built-in given A is equal to 10 meters per second squared. We know that the building is 10.1 meters tall, again tall being that key word that tells you it's a vertical displacement. So our dy is equal to 10.1 meters. The ball lands 27.7 meters away from the base. Again, those are key words that tell you that that is a horizontal measurement. So our dx, our horizontal displacement, is 27.7 meters. We're looking for horizontal velocity, or vx. Our equation for vx is dx divided by t. Again, we're missing the time. So we go to our equations, and only one will work with the information we have available to us. And again, that is t equals the square root of 2 times dy divided by a. When you plug in your values, you get 1.421 seconds for our time. Plug time into our original equation to solve for horizontal velocity. 27.7 meters divided by 1.421 seconds. And you get a Vx of 19.5 per second. Question number 4 is a little bit more complicated, and I do want you to pay attention to this because you'll be doing this in a lab. Number 4 says a lab group rolls a marble off a ramp that is 1.42 meters off the ground. The marble's horizontal velocity as it leaves the ramp is 1.511 meters per second. Find the marble's resultant displacement. So let's look at what we know. Again, we have our automatic built-in acceleration is equal to 10 meters per second squared. Our ramp is 1.42 meters off the ground, so that's a vertical measurement. Our dy is equal to 1.42 meters. The horizontal velocity is 1.511 meters per second, so that's our Vx. Ultimately, we are looking for the resultant displacement. And for a resultant, think back to when we discussed vectors, or when you have two vectors that make a right triangle, as dy and dx would, the resultant is then the hypotenuse of the triangle. There are several steps that go into finding the resultant displacement in this case. So step 1 is to solve for dx. We have our dy given to us, but we don't have a dx. So we need to find that first. The first part of that is our equation. Dx is equal to Vx times t. Well, we don't have time. So our next step is to use dy and acceleration to solve for time. Square root of 2 times dy over a. We plug in what we know, and that gives us a time of 0.5329 seconds. Now we use time and Vx to solve for dx. Plug into our equation, and we get a dx of 0.805 meters. So now we have the two legs of our triangle, and we just need to find our hypotenuse. Remember, to do that, we're going to use the Pythagorean theorem to solve for that resultant. And in this case is going to be dy squared plus dx squared is equal to our resultant squared. Substitute in the information you know, 1.42 meters squared plus 0.805 meters squared. And here's our intermediate math. We know that our resultant is going to be the square root of 2.6644 meters squared, and ultimately our resultant displacement is going to be 1.63 meters. And a clue to check yourself is your hypotenuse of your triangle should always be longer than either of your legs. 1.63 meters is longer than your dx, and it is longer than your dy. So you can check and say, yes, that is a reasonable answer. And question number 5, very similar to number 4. A lab group rolls a marble off a ramp that is 0.996 meters off the ground. The marble lands 0.683 meters away from the base of the ramp. Find the marble's resultant velocity. So again, we have our built-in acceleration equals 10 meters per second squared. Our ramp is 0.996 meters off the ground, so that's our dy, our vertical displacement. The marble lands 0.683 meters away from the base. Those are our key words to tell us that that is a horizontal displacement, or a dx. And we're ultimately looking for the resultant velocity. We'll notice that we don't have either velocity given to us, so this one has a little bit more steps than the last question. So our first step is going to be to solve for Vx. We know our equation for Vx is dx divided by t. We don't have time, so we need to solve for time. And we're going to use our dy measurement to do that. Square root of 2 dy over a gives us a time of 0.4463 seconds. When we plug that into our equation here, using time and dx to solve for Vx, we get a horizontal velocity of 1.530 meters per second. That's this top leg right here. But we still don't have the second one. So our step 2 is going to be then to solve for Vy. You don't do this one very often, but you have the equation for it, and that is Vy is equal to a times t. So we take our acceleration, 10 meters per second squared, times our time, 0.4463 seconds, and we get a vertical velocity of 4.463 meters per second. Now we have both legs of our right triangle, and we can solve for the hypotenuse. So step 3 is to then use the Pythagorean theorem to solve for our resultant. Vy squared plus Vx squared is going to equal the resultant squared. So that gives us a resultant is equal to the square root of 22.259 meters squared per second squared, or our final answer being 4.718 meters per second. Again, we know that that is slightly larger than our Vy, and it is larger than our Vx, so at least you can tell that that is a reasonable answer.